I've already explained to you in prior videos why it's critical to move to Linux. I'll just restate it in one sentence. Only Linux can offer us privacy. Other operating systems are inserting privacy invading features constantly that we have to avoid at all costs. However, switching to Linux always has complications. You need to be able to do things that are trivial in Windows but are very complicated in Linux. And you will need to use the command line. No escaping that unless you are a browser-only type of user. So today I will give you some really common but critical things you need to do in Linux, and I will show you how to do it using a command line. This stuff will trip up even someone who's already exposed to Linux. These are the kinds of questions that will get you nasty responses from Linux experts. So we will avoid those folks and explain it here. Ready to take notes? You will need to. And when you've got your notepad, stay right there. This tutorial will be targeted to someone who just moved to Linux, has some idea of what's going on, perhaps from Windows, but will likely be searching the interwebs for solutions that I will discuss here. I expect that most new users will be on Linux distros that are Debian-based, so that will be our premise. Examples of this are Ubuntu, Mint, Pop! OS, and Zorin. So that's the target audience. Bear in mind that methods I will explain may be different for Arch, RPM, or other non-Debian-based distros. I will always recommend that new users stick to Debian-based systems. Otherwise, you will likely be confused by instructions since they may be different. Most of the stuff we will do today requires the use of terminal, which you will find in the Show Applications window. We will be typing commands in the command line on terminal. That's the terminology. Since it is used frequently, I will typically add terminal in my favorites taskbar. I'm just going to go through this extremely quickly, more like a review. In terminal, to navigate through the different directories, which is a tree structure, the command is cd/directory. And just specify the tree hierarchy using the / like cd/home/worker/documents, which goes down 3 levels. This is the same in Windows, except in Windows the slash is a backslash. ls-l lists the files in the directory. Here's a quick example. cd/home/username. This is your home directory, by the way, and my username here is worker. Now here's a shortcut to access your home directory. cd squiggly character. Now let's edit a text file. To do that, we just use the program called nano. The syntax is sudo nano filename. Examples: sudo nano /document/test.txt. And now we have a blank document. Type some stuff, then use Ctrl-O to save and Ctrl-X to exit. Or change directories first. And then use nano without a directory as I show here. cd /documents sudo nano test.txt. Same thing. Sudo in front of a command ensures you have root rights. Some commands will fail if you have no rights. That's why you always see sudo. In Linux, everything is really a directory. There are no drives or special area for drivers or devices. Everything is in a directory, as you can see here. I'm using the term directory, but the user-friendly term is folder. So these terms are interchangeable. Let me switch to calling it folder. These folders can be accessed via the Files app. In Linux, each folder is given a specific purpose. I'm just giving these examples as these are the ones we'll be working on today. So for example, all devices are in /dev. Most system setup is done in /etc. And user files are in /home, which also has documents, downloads, music, pictures, videos. And most apps are installed in some of the /bin folders, which by the way means binary. All app icons are in user share applications. The reason we do not use the Files app for system changes is that Files does not get sudo rights. So this is why we use the command line if that permission is required. Now here's a trick to use both File Manager and Terminal simultaneously. This will avoid having to use CD, and it's just faster navigation. Just go to your Files app and right-click on any empty space and open Terminal, and you will be in the current directory in that session wherever Files app happens to be pointed to. For this example, I'm using an SD card that I inserted into my laptop. By default, SD cards are pre-formatted to use the FAT32 file system. This has space limitations and is not suited to hard drives. So the best file system that is compatible with other operating systems and can be used on large storage devices is called exfat. We can use exfat for any secondary storage device, but on Linux, the main partition has to always be the ext4 file system. So you can't use exfat on everything. But if we format using exfat, then it can be read by both Linux and Windows. If you're doing dual boot with Windows, for example, this will make your experience less error-prone than using other file systems like NTFS. The first command will show the storage devices currently available on my computer. lsblk-l-e7. As you can see here, my system is fairly complex. I have a USB stick, an SD card, an SSD drive, and lots of partitions in each. First, you will see storage devices prefixed with SDA as shown here. In this case, mine is a USB stick. Other devices like magnetic disks will often use SDA or SDB and so on as prefixes. Those devices marked as MMC are typically SD cards. And NVMe is an SSD flash drive. So just look at the first part of the name as a clue. If you're confused as to which is which, just look at the size of the disk, and that may give you a clue. For example, I see a device that starts with the name MMC and is approximately the same as the 64 gigabyte card I have in my slot. Also note that each drive is listed and then separately each partition is listed. This is something basic even in Windows. Storage devices may have multiple partitions, but we won't get into that. When you buy a fresh disk or SD card, it will have one partition. Just look at the list and you will see that there are items marked as disks and ones marked as partitions. By the way, in Windows, each partition is just assigned a drive letter, often starting with C. So in this way, Windows is easier. But Linux has more flexibility, especially with more complex configurations. Formatting is always targeted to a partition. So just pick the partition you need to work with that you want to format. In this case, I will format the SD card, which is MMC block 0 disk. and then specify the first partition. So mmc block 0 P1, the P1 indicating the first partition. Now let's format it now with this command. Sudo mkfs.exfat -n mysdcard /dev/mmc block 0 P1. You will see here that the device name is appended to dev, which indicates that you're referring to a device. The optional -n gives a name to the media, and in this example, I called it mysdcard. If the mkfs command is not found in your system, then install it with this command. Sudo apt-y install util-linux. This is such a common request, and it's so trivial on Windows. In fact, on Windows, you do nothing special. You install your hard drive, and assuming it's partitioned and formatted correctly, again, something Windows users know about, it just works. But on Linux, it doesn't just work. By default, devices need an extra step called mounting. If you don't mount a device, it's not visible. What we will do now is to always make sure that when we turn on our computer, the storage device is always pre-mounted. In this example, we are presuming that your storage partition is formatted using exfat, as I explained before. The very first thing we need to do is to find the unique identifier of our storage partition, which is called a UUID. The easiest way to do this is lsblk -f-e7, which shows this. As you will see here, all the devices are listed, but there is a column marked UUID. In my particular case, the UUID of the mmc block 0 P1 device is shown here. So make a note of your UUID because that's the partition we will mount. Now run this command, sudo nano /etc/fstab, and you will see the nano editor with the Fstab contents. Fstab is the file system mounting instructions for Linux. You will then paste the text I'm showing here as one line on Fstab. The UUID is my own, and that will be different for you. Username is your username and will of course also be different for you. And the folder I show as home username documents, SD, is where I choose to place my device, which is again up to you. Now the rest of the values here should just be taken as is. This should work for most scenarios, so just copy it exactly. I like to put my devices in my Documents folder because it is always accessible and easy to find in the Files app. Now, in order to mount this device into that folder called SD, it must exist. Currently, it does not exist. So the final step is to go to Files and make the SD folder in Documents, and we'll just use the Files app. Or via command line, it is mkdir /home/username/documents/SD. Then the only thing you need to do here is reboot, and then you should see the new drive or SD card in your Documents SD folder. Installing apps should be trivial as it is with Windows, but it's not. On Linux, there are so many ways of installing apps, and it is really difficult to figure out because no one explains it to you. Not even the app developers who give you a download. So we're going to talk about 5 ways to install apps and then also show you how to make icons for the apps, since that is not always provided. On distros like Ubuntu, many apps are available on the Ubuntu store or whatever the store is for that particular distro. In my case, it's the Pop! OS store. But I usually don't rely on the store as the version may be slightly different, so I go to the website of the app developer to see what their instructions are. But a common example is where the app developer tells you to use the command sudo apt install and then whatever their app name is. Here's an example using Brave browser. Sudo apt update, sudo apt install brave-browser. So that's simple enough, but there are assumptions made here. This assumes that the developer has the latest version of their software on the apt repository of Debian. What's happening here first is that the update command refreshes the software index from that apt repository, which is managed by Debian. This is important to get the latest version. Then the install command downloads the file and installs it. A repository is like a store where developers will place their code, and each major Linux distro maintains such a repository. The Debian one is called apt, Advanced Packaging Tool. The problem is that some developers will keep their stuff in their own repository, or you have additional stuff being done, and then you get new strange commands. Just to teach you something for your own basic understanding, if you go to the etc apt folder and open the sources.list file, you will see the repositories preloaded on my distro. If a developer wants to point to their own repository, they will give a command to update the repositories with a command like this: sudo add apt repository, and then the location. And this will update the sources.list file. I'm just showing you this as an example. Each developer may add a repository that's in a different format, but this will be in the app's installation instructions. And this just updates the sources.list file. There are two popular package installers in Linux. One is Snap and the other is Flatpak. Sometimes the developer will include a Snap option, and this is common for Ubuntu. The Snap packaging was created by Canonical, the developers of Ubuntu. If you install an app from the Ubuntu store, these will be Snap packages. You can install Snap packages from a command line like this: sudo snap install Firefox, using a Firefox example. Again, you're just following the instructions of the developer. If they have a Snap option, then this is all it takes to install it. Some people like to use Snap and some don't. If it's an isolated app, then Snap is usually fine. If the app has to interact with the system, then usually Snap is not the best way. In any case, the app developer will tell you how they want it installed. What's unique about Snap packages is that they're self-contained, so they don't interact with other existing software on the system. This makes them reliable when there are versioning issues. Now, Flatpaks are similar to Snap. They're also self-contained. Their command is very similar: Flatpak install Firefox. But to set up Flatpak requires a lot of commands that you need to run once, and here it is. To be honest, I never used Flatpak because these commands were never handy, but now I've made it handy for you, so just cut and paste. Sometimes the app developer will just give you a deb file to download. And of course, a Windows user will just click on this expecting something to happen. Nothing will happen. This is because this is just a packaging of an app that is exactly in the same format as you would find in the Debian repository. It just needs an installer. You could use File Manager and select Open the file with other application, and then select Software Installer, and that will install it. This is something most new Linux users do not know. The deb file is actually the same format used by apt when it downloads from the apt repository. So you can also, from the command line, just use apt install like this: sudo apt install, and then the deb file name. Thus, a deb file is just being given to you directly and is bypassing the repository. This can be dangerous if taken from an unknown source. So some developers, like Firefox, want to check it against a signing key. Here's an example of the complex instruction from Firefox. So here the developer is asking you to set up a signing key. You just cut and paste the tedious instructions to the terminal, so absolutely no memorization is involved here. But it is overwhelming to see so many commands, so if there's an option to not use a raw deb file, then that would be a safer method and usually easier. A developer may provide the software as a file with an appimage extension, and you download this and click on it and nothing happens. More Linux confusion. Now, this one is actually simple at first, but needs extra steps because by default, the app has no icon to click. I'll deal with the icon later. In the meantime, the easiest way to make an app image active is just to go to Files, find the app image file in your Downloads folder, and then activate the Execute permissions. And then when you click on the app image file in Files, it will actually run. Now, the interesting thing about an app image is that the whole software is in this one file. This makes it very easy to manage. It is self-contained, like a snap package, and doesn't require other apps to run. Here's the important tip. You do not want to leave your app image file in your Downloads folder. Officially, documentation for Linux recommends that the app image files be moved to the /opt folder. However, this is not easy to access and is not really necessary if you're the only user. My method is to just make an apps folder in Home and copy it there. And that's where I put all my app image files. Assuming they're given app execute permissions from Files, it will be easy to find and easy to run. The problem with app image files is that they do not come with any icons. So here we are left with another manual command line process to create this icon. Icons are useful because they allow you to put an application in your favorites taskbar, and it allows you to find it in Show Applications. So let's show you how to make an icon. Desktop icons on distros like Ubuntu are kept in User Share Applications. So if you list the contents of your applications folder, you will see a list like this. And this will match all the icons in your Show Applications window. For this example, we will create an icon for the app mkfs.exfat app image, which is my preferred password manager, as I said. To create an icon, I can just use nano to make a text file with the name mkfs.exfat.desktop, or the name of the app .desktop. And then the format of the contents is shown in the example here. The important thing here is the location of the app image file, which I specified in the exec area. As I explained, I tend to keep my apps in my home apps folder, and separately I downloaded some icon from the internet in PNG format and put it with the app image also in the apps folder. Search the internet for a ping icon file for the app in question and you will find one, or just use any other icon. After you save this file, you will now see that the icon will be callable from the Show Applications area in your distro. And if I search for it, I can then add it to my favorites taskbar. Some developers will just give you an sh file, which means it's a bash script, and this will be something you just execute and it manages the installation. This is the same concept as the Windows batch file. The only important thing here is that by default, an sh file will not automatically run. You have to give it execute permissions, just like I described for other files before. You can do it in the Files app. But just as an advanced technique, you can also give execute permissions via command line using this command: sudo chmod +x and then the file name of the sh file. Of course, specify the proper location and folders of the file name. Then you can execute an sh file from that folder like this: // and then the file name of the sh file. The // is there to prevent Linux from searching everywhere for this .sh file. This will execute the one in the same folder. Installing the VPN on most Linux distros is extremely easy nowadays. All you need really is the OVPN file from your VPN provider. Download that and it should be in your Downloads folder. The reason it is super easy is that the OpenVPN is pre-installed on all popular Debian distros that I'm aware of. I tried them all. In fact, it was installed in most Arch and RPM distros as well. To access it, I just go to Settings, Network, and you will find VPN Settings. Then there is a plus sign on the upper right-hand corner. When you tap on that, you get the option Import from File. Then you find your OVPN file in the Downloads folder. After selecting the OVPN file, it will pre-fill your entries as shown here, and you do not need to do anything else other than put in your username and password and hit Add. Then just switch the VPN to on whenever you want to use it. Now, there is a very long instruction on how to set up OpenVPN to start automatically, but there are a lot of steps and you need extra steps to turn it off since it won't rely on the network manager in settings anymore. You will rely instead on systemd by turning the service on and off, which is all command line. So I don't necessarily recommend this as it is not really designed for the average user. So there you go. These are kind of complicated, as you can see, compared to Windows. Usually though, this is only done once, and so it's not as bad as it looks. And most of this is just cut and paste, and you don't need to memorize anything. Only Mr. Robot can remember every Linux command and hacking stuff on TV. The rest of us require notes, and we all cut and paste. If there's something else you'd like me to expand on, just pop your requests in the comments, and I can do a follow-up video. Folks, I started a company to develop privacy-oriented tools for use by people who care about privacy. Our store and our community are all on my platform, Brax.me. We have products like the Brax Virtual Phone. This gives you no KYC voice over IP phone numbers for texts and calls. We have the Google phones that are no identity devices and have nothing that makes them visible to big tech. In other words, invisible phones. We have the Brax Mail service, which is a no metadata email service with many domains and unlimited aliases so you can have multiple email addresses. We have the Bytes VPN service, which protects your IP address. All these and other products are on the store on my app, Brax.me. Join the over 100,000 users that discuss privacy issues daily and be part of this community. Thank you for watching, and see you next time.